I'm going to actually start over because I wanted to make sure that we recorded the session. We wanted to welcome Dr. Chang, and we thank you all for joining us today for ATD NYC's webinar, Optimize Your Learning Through Programs Through Lessons from Neuroscience. We're so excited to have Dr. Chang presenting today. She loves the outdoors, and she joins us from the Denver, Colorado area, where she is the Director of Research and Development for the Regis Company. As Director of Research and Development, she leads research initiatives, assessments, and is responsible for driving the neuroscience thinking of the organization to help build brain-friendly learning solutions at the Regis Company. Grace is also lead professor at the Neuroleadership Institute, where she teaches courses geared towards applying brain science and research to improve human performance, develop leaders, and drive change. We really appreciate Marshall Bergman, also from the Regis Company, for making the introduction to Dr. Chang. Dr. Chang has a lot of exciting material to share today, so I'll let her take it away and start the presentation. Dr. Chang, are you there?
Yes, I'm here. Thank you. I'm just trying to take the ball.
Okay.
Having a little difficulty. You might have to share it with me.
There you go. It just
great. Thank you so much.
It's acting a little bit slow. Okay.
Thank you.
We're not seeing your screen, Dr. Chang.
Okay, I'm not getting the sharing option. Sorry. Hold on just a second.
You should have it.
I got it there.
Great.
Great. Thank you.
Yeah.
So you should see a blue screen right now, and I'll share my slides.
Yes, we do. Thank you.
Okay, great. Thank you so much. Thank you, Julie. Welcome, everyone. So as she mentioned, I'm going to be talking about optimizing your learning programs with lessons from neuroscience today. So before we start, I want to start with a question. I want to just see where we are with things. So we have a polling question. Which best describes how you apply knowledge from neuroscience research findings to your work? So if you could answer this polling question, that would be great.
Okay, if you look down in your polling box, that poll is open right now. Okay, we have some people actively participating, and we thank you. We'd love to see some more participation before we close the poll. Okay, we'll give it about 20 more seconds before we wrap it up. Okay, thank you. Okay, closing the poll. All right, it looks like most people are not familiar.
Okay, that's good to know. Well, you're here at the right place then. Okay, great. So we'll be talking a lot about that today then. So let's start. So the issue, I think we're all familiar with what the issue is. The issue is that when we're developing learning programs, you know what you want people to learn, or you have some good idea of what you want them to learn. You have a learning target. And this is ideal, where you're smiling like this guy is, and you're confident, and you can hit the bullseye every time with your learning programs. This is what we all hope for. But sometimes when we're learning programs, it can actually feel a little bit more like this. So even if you've been doing this for a while, you may sometimes feel unsure of what you're doing. Maybe you're doing what you're doing because that's what you've always done, or what you've seen others do. Maybe you aren't sure that what you're doing is actually brain-friendly. Or maybe you are intuitively designing good programs that you think do have an impact, but you can't quite point to the reasons why what you're doing is effective. So knowing this why is helpful, so you can not only look and feel really confident when presenting and defending your program to others, it's also important for thinking about how you can improve your program. And this is where the neuroscience comes in. So knowing what neuroscience research says can help you make sure that you're considering how the brain learns best when you're developing your learning program. And in some cases, this might mean replacing outdated practices or even just modifying your practices a bit. In other cases, it may be more about just being aware of the why behind what you're doing so you can be more intentional in your planning of the learning program. So there are different types of learning programs out there. Some are meant to help people develop an insight, shift how they think, while other programs are more focused on getting people to learn specific, concrete content knowledge. Neuroscience can help us in developing either kind of program. So I'll be covering both to some degree. So I'm going to first start by talking about how we encourage insight, and then talk about making learning sticky. So how can we make that concrete information stick, and the insights as well. And this will all be followed by a Q&A at the end. And along the way, I'll give a few examples from what we do at the Regis Company, just to give you a sense of how you could apply some of these principles. Now, even though some of our examples are from simulations, because that's what we build here, you don't have to build simulations to use the principles I discussed. So I really encourage you to think about how you can apply these principles to your specific work. So let's start by talking about encouraging insight. So Nobel Prize winner Daniel Kahneman characterized two thinking systems of the brain. System one, the faster system. It's very automatic. So this is a system that responds very automatically to things. And this system is associated with the unconscious. So it doesn't require conscious awareness. Now system two is still fast, but relatively slower compared to system one. And it's a more controlled system. It's associated with more complex thinking. And this does require consciousness for this system. Now, in parallel with Kahneman's work, years of neuroscience research have given us a sense of which brain structures are associated with these thinking systems. So it seems that for system one, that seems to involve structures like the amygdala and the basal ganglia. And let me see if I can find my pointer. Okay. So you can see collectively several of these structures make up the basal ganglia, and then you can also see the amygdala. So this is the front of the brain, the back of the brain. And we're looking inside the brain right now. So basically, system one, these structures use well-established patterns of habits to quickly and very automatically react. So some of you might have heard about the amygdala and the fear system, how the amygdala, when there's something fearful, it processes it and it causes a very automatic reaction, a lot of times before you've even consciously become aware of what's fearful. So that's because it's this unconscious system that's acting very quickly. Also, the cognitive biases or the mental shortcuts we use on a daily basis to make snap decisions are associated with this system. Now, system two involves many parts of the prefrontal cortex, an area of the front of the brain that is especially developed in humans. It's more deliberate, it's involved in complex thinking, focused attention. It helps us weigh different options and think about alternatives. Basically, it does all that complex thinking that humans are so known for. Now, both systems are important, but they have different roles. So system one is used more often, and that's because the prefrontal cortex has limitations. It tends to tire easily, so we have to rely on system one to go about our daily lives more. It handles all the habitual things we do on a daily basis. Our conscious system, the prefrontal cortex, or system two, can really only handle one conscious process at a time. It's very linear in how it produces things, while the unconscious processing system one can handle multiple streams of information. So I'm bringing up these systems up in the structures because they're relevant to how we gain insights, and understanding more about how these brain regions work help us to consider how best to encourage insights. So what exactly is an insight? Many define it as a sudden change in the knowledge representation, often leading to the solution of a problem. So you may be stuck on a problem, and you may have an impasse and just can't figure it out. And then suddenly you have that aha moment of insight with a problem solution. However, insights mean different things to different people, so it's probably not surprising that there are varying ideas about how best to encourage insights. So I'll talk about some different kinds of insights today. I think there's a role for both systems in insight, system one and system two, depending on how we define insight. So now I want to ask you guys a quick question. Have you ever had a sudden insight about the solution to a problem when you weren't even thinking about the problem? So it just came out, it seemed like it came out of nowhere when you were thinking about something completely different.
Okay, so the poll is open, and looks like we have just about everybody is finished. We'll give you another 10 seconds for those few last folks who are in the process. Okay, and we're going to close the poll. Okay, it looks like 85% of the audience says yes.
Okay, great. So you had this sudden insight when you were doing something else, and it probably seemed really sudden, like it came out of nowhere. Even though it feels sudden and surprising, like it comes out of nowhere, they actually aren't. And that's what this slide is meant to show you. There's some fairly consistent patterns of brain activity that seem to occur both before and during insight. So before the moment of insight, where that yellow arrow is, there's an increase in alpha waves in the brain. And this type of activity is associated with attentional gating. So basically that means that you're starting to shut things out. So you're focusing your attention more inward rather than on external things. So it's quieting down your system. And that may be helping us get to insights, because a lot of times we have weak associations in the brain that can be used to solve the problem. So we need to, put all those connections together. But those associations are often normally overlooked because of all the noise that's going on from outside. So quieting things down can help us get to those insights and make those connections. Now you notice when our system is most quiet during this attentional gating, we get this burst of gamma wave activity, which is the green line here. And that's associated with the insight. That's when you get that sudden aha, conscious, oh, I've got it, eureka, right? And it's often happening when you're not directly focusing on the problem because you were focused inward, doing some mind wandering or something like that. So you're on a run or you're mind wandering, and it seems like this downtime and the unconscious processing that's occurring seems to help to lead to these insights. So what's important here is that when you're not consciously thinking about a problem, your brain is still unconsciously making connections that help lead to the development of insights. So one tip from the neuroscience is, after you've consciously thought about and defined a problem clearly, it seems to be helpful to build in some downtime for mind wandering so your brain can make those connections that lead to insights. So that's one way system one is involved, the unconscious system is involved. Another thing to consider is the learner's emotions, and that also has to do with system one because that has to do with the amygdala. So our amygdala is important for processing emotions, but it's especially sensitive to negative emotions such as threat. So a threatening atmosphere or a really negative atmosphere is less conducive to insights because it narrows our thinking. So we're less likely to bring in all the possibilities, all those weak associations that could help us develop an insight. Instead, our attention is drawn to the threat, and we become so focused on that that we're not getting all those connections together. And there's a reason why we're drawn to that threat. It's because evolutionarily it makes sense for survival, but it's not good for insights. So that's one thing to consider when you're developing your learning programs. Now, at Regis, we talk about insights a little bit differently. We're not always talking about that sudden aha solution to a concrete problem. Sometimes the insights what we're talking about are about encouraging a shift in how people think in learning programs. And we think this is critical because thinking drives people's behaviors or decisions. So we help people realize that the previous way of thinking was flawed or at least limited, so we can help them shift how they think about the world. So we do this by using simulations to simulate situations that learners might actually face in their real world. So because time is compressed in a simulation and there's less noise than there is in a real world, people can more clearly see the relationships between cause and effect. So for example, when they make a decision, they can not only see how their decisions impact their own outcome, but they can also see how their decisions impact other parts of the organization and how that in turn feeds back and affects them. So they can get a more systems view of things. So a practical example of this is helping people in a new role to think differently. So you can imagine how first-time managers have to think very differently and make different decisions than the decisions they made as individual contributors if they want to become successful managers. So that's the kind of thinking that we try to get people to do. So we want people to essentially question their established thinking habits or biases and consider new ways of thinking that are important for their success. And to do this, we get learners to engage in system 2 thinking, that critical thinking, so that they can think about alternative ways of thinking and get to those kinds of insights. So system 2, or the prefrontal cortex, or PFC, it's very picky. I've already told you a couple of limitations, but it also has an optimal amount of arousal. And by arousal, I'm just referring to the chemical environment in the brain. So this graph shows how it functions best when it has an optimal amount of arousal. So what we like to refer to as a sweet spot is when the prefrontal cortex is most attentive, most organized, most able to do complex thinking and think about alternatives, weigh options. And this is also when people are most likely going to be able to reach the kinds of insights we're encouraging in our programs. However, if people aren't aroused enough, if they're too bored or not engaged enough, they don't have enough arousal, and so their prefrontal cortex isn't working at its best. Also, if they're too aroused, it's also not working at its best. So we have to get people to that sweet spot in our programs, and most people naturally are to the left of it. So they need some sort of arousal to get to that sweet spot. And so there are different things we can do. We can introduce some novelty, some uncertainty, some teaming, some role-playing, different things to increase the arousal to get people to the sweet spot. We can also increase arousal by making things more relevant to individuals and introducing even some stressors. So for example, we could introduce competing priorities, some deadlines, and competition. But it's a balancing act, right? Because on the one hand, we do want to mimic real-world situations to some degree because we know from research that learners will be more likely to transfer their knowledge to the real world if they learn the lessons in a similar context. But at the same time, we all know that the real world sometimes involves some very negative emotions, right? It can be very stressful, very threatening. And if we introduce too much stress or negative emotion into the program, we can push people over the edge, and then their prefrontal cortex won't be at its best to do the kind of thinking we need. So that's one reason why you always have to be mindful of this when you're developing learning programs. You can include some stress, but not so much that it pushes people over the edge. And this is another reason why we do a lot of pilot testing before we roll out any programs. So I've already said we want to engage System 2, the prefrontal cortex, to get people to think critically so we can shift their thinking. But I also just said that we're more often using System 1 because of the prefrontal cortex limitations. So how do we actually tip this balance so we get people to shift from System 1 to System 2 thinking when we need the prefrontal cortex to do some critical thinking? And that's where the anterior cingulate cortex, or the ACC, comes in. It's the error detector of the brain. So when it realizes that something's unusual or a mismatch, it becomes active, and it alerts the prefrontal cortex that it needs to do some sort of complex thinking. So an example I like to give is driving to work each day. When I drive to work, it's 18 minutes, give or take a minute, door to door, without fail, as long as everything goes as normal. And so it's a well-ingrained habit because I drive the exact same way to work every day. And so I'm using System 1, my very automatic habit system there. And that works great unless something unusual happens, like if there's a roadblock for some reason. Then I can't use my habits anymore. I have to think about alternative routes. So what happens when I get to that roadblock is the ACC becomes active, the error detector. It says, uh-oh, System 1, you can't handle this anymore. System 2, you need to get online and do something. So it basically gets the prefrontal cortex, System 2, to become active and start doing some of that complex thinking so that I can think about alternatives. So if I go right, what will happen then? If I go left, what happens that way? Okay, and that's the kind of thing we're trying to encourage in our programs. Get people to think differently from how they normally think. So here's just one of many examples of how we can activate this ACC error detector. So for example, we can have a learner in a simulation make several decisions to try to increase something like product revenue. And then we can show them a diagram like this, which shows the results of their decisions. And as you can see, they did increase product revenue, but they also had a lot of unintended negative consequences. You can see that in red here. And so when we show this to people and we have a debrief around this, they realize that something unusual happened, something they didn't expect. So this triggers the error detector, the ACC, and that'll cause the prefrontal cortex to engage and start thinking about why this might be. You know, it starts to think critically about how might I do this differently next time, that kind of thing. So given what we know about how the brain works, I think there are two key challenges to focus on if you want to get people to think differently. The first is optimizing System 2 functioning. So you want to make sure the prefrontal cortex is rested and can be aroused to the sweet spot on the curve when needed for complex thinking. And that's because of the normal limitations of the prefrontal cortex. The second is actually triggering System 2 thinking at key times when we want learners to get insight. They are somewhat related, but there are some differences here, some nuance. So let me give you an example. So this is a very oversimplified example of one of our simulation programs and the kind of arousal that happens during it. So at the beginning of a simulation, people get introductions and they get a storyline, and that increases arousal because it's new, it's interesting, they're starting to learn what they have to do. And then they get to round one of the simulation where you have to make lots of different decisions. This is definitely arousing. And then they get to a debrief. This is where the facilitator asks a lot of questions, and you would expect high arousal then. And then there's a break, and during the break, arousal goes down. And then again, you go to round two, you have more arousal, debrief, more arousal, etc. So you notice this up and down pattern, right? And this is very deliberate. The whole point of this up and down pattern is to give the prefrontal cortex the rest it needs so that it can be at its best when we want it to be at its best. And so that when we trigger it, it'll be well rested so it can do its thinking. And so we would want to actually trigger System 2 thinking during these simulation rounds and debriefs, and also during the present and defend. These are the times during our program when we think people are most likely to develop insight. And so we want to do something to make learners examine or question their thinking. And so what we do, I mean, obviously during the rounds, one thing that can happen is the example I showed you, where they see that their decisions had unintended consequences. And so when they're confronted with that, that can definitely get them to examine their thinking. Also, during the debriefs, we have facilitators asking very thoughtful, difficult questions that make them think critically. Okay, so these questions are not easy. It makes them pause, and they have to use System 2 or the prefrontal cortex to answer these questions. So these are some examples. What was the rationale behind your decision? So this causes people to engage in deeper levels of processing because it's not an easy thing to answer. What are your predictions regarding the outcomes of these decisions? Why? So this makes people think about the future, and that leads to more abstract thinking, which often leads to insight. It also promotes more systems thinking when you think about predictions and how it affects other people as well. What are the similarities between your experience and the simulation decision? So this really makes the learning personal. It really makes them relate to the simulation experience. How would you apply this decision to a different project, scenario, or client? So not only does this make it personal, but it also makes them have to think about how they would apply this information. So this really promotes transfer of learning. Okay, we have a white paper from our organization that we'll share with you. That's one of the things that Julie's going to send out tomorrow, and it has a lot of information about these kinds of questions and encouraging System 2 thinking. But I want to just ask you guys, what are some questions you would ask to trigger System 2 thinking in your specific line of work? So I'm just curious if you have any thoughts about how you would apply this. And if you want, you can go ahead and, sorry, go ahead.
Yeah, go ahead. I was just going to say, remind everyone, you can go ahead and type those into the chat box. And again, I'll just take this opportunity to remind everyone, as you develop questions, as we go through the presentation, please feel free to enter those into the Q&A box, which is different than the chat box. Thanks.
And there's no right or wrong answer here. I'm just curious, because I know we all come from different areas of learning, and I'm curious how you would apply this information. So what kinds of questions would you ask of your clients to get them thinking in this way?
Oh, I see. Marshall entered into the Q&A. How did you feel during that experience?
Yeah, that's a great one. That gets them in touch with the emotional aspects and definitely makes it personal there. I see Tina's saying, how will you apply this knowledge back in your workplace? Yeah, that's great. I think that's a great way to get them to think about application. Autumn is saying, I would give user a scenario that would be related to all learning topics. Yeah, definitely. So there's different ways you can apply this. We've definitely asked them other questions like, how would you communicate your decisions to leadership, to the client? And that involves mentalizing or perspective taking, thinking about what's going on in the minds of others, and that can really promote more systems thinking. Any other thoughts? So I'll give you a few more seconds in case anyone's thinking about anything, but if not, we'll move it on. And I know it can be difficult to think on the spot like this, so I encourage you to marinate about it, and something will probably pop up for you later. So,
and feel free to enter that into the box, and we can cover it later. Oh, it looks like some people.
Yeah, I see Autumn has said maybe ask if the knowledge could be useful for the organization. Yeah, I think if you ask them how is it useful, that makes them really try to think about, well, how do I apply this? How does this make sense in my world? How is it self-relevant? And I'll talk a little bit more in a short while about why self-relevance is important in learning. So thank you all for participating. Okay, so just a couple tips to summarize how we can encourage insights. So first of all, building in some downtime or rest into programs. This has a couple of different purposes. One is it promotes that internal focus and mind-wandering time that can help lead to the aha, those sudden insights I talked about that involve the unconscious. But it also can provide the prefrontal cortex with necessary rest to optimize its functioning. So it considers the limitations of the prefrontal cortex when we do this. And then it allows us to encourage system 2 thinking at key times. And so we want to encourage that system 2 thinking, that prefrontal cortex thinking, that complex thinking by triggering the error detector. And I've shown you a couple ways of how we can do that, by having people confront things that are a little unusual, unexpected, or even asking them tough questions. Also, consider the mood, the impact of mood on developing insights. So we know that strong negative moods, especially threats, really prevent us from getting to insights because our prefrontal cortex isn't working well, and it also draws our attention away from those associations, those unconscious associations that might help get us to insights. So that's something to definitely consider when planning programs. So I'm going to jump right into the next section. I know you probably have some questions, but add them to the Q&A and I'll get to those at the end. I just want to make sure we cover all this material. So the next section is definitely relevant to insights as well, but it's especially important for targeting learning and memory of specific content knowledge. And I called it making learning sticky, but it's really more than that. It's really about how we can help people acquire knowledge in the first place as well as making it stick. So there are a few steps that have to happen for us to learn new information, store it, and then later use that information. So encoding has to do with acquiring the information in the first place. And what happens is there's a temporary change in how our neurons, our brain cells, communicate with each other. And that allows information to be held for a short while. Now what happens is it's held for a short while, but information will slowly degrade and be forgotten if we don't do something about it. So encoding is temporary. But then what happens is some information will undergo consolidation. So if it undergoes consolidation before it's forgotten, what will happen is some more permanent biological changes happen that essentially transform the memory from a short-term memory into a long-term memory and allows it to be stored. And if it's stored, then at later points in time, you can retrieve the information from long-term storage to use that information. So this is what we want for all our learners, to be able to use their information, right? So this essentially is about acquiring, storing, and accessing information. And we can have an impact on learning and memory by affecting these different steps, especially the encoding and the retrieval steps. In terms of the brain structures, the prefrontal cortex that I already talked about, that seems to be important during both encoding and retrieval. And the hippocampus, a very important memory structure, is also involved in these processes. It has an added role in that it's very important for consolidation, that process that transforms a short-term memory into a long-term memory. Once information is consolidated, it's stored throughout different brain areas, so it's not as dependent on the hippocampus. But if your hippocampus isn't working properly during that consolidation period, you don't get to transfer a short-term memory into long-term storage. So you won't develop long-term memories, and that's really problematic. And I'll tell you why that's problematic in a second when we get to emotions. So I like this framework developed by the Neuroleadership Institute because it summarizes some of the key learning and memory research. And the idea is that by following these principles of the ages model, you can help develop learning that will last through the ages. So develop learning that will stick. So I want to just ask you guys, how familiar are you with the ages model? Have you heard of it? You know, where are you with this? I'm just curious.
So we have an open poll to the side there. Did it open? No answer.
It says the poll has ended.
Oh, geez. Okay. Well, sorry about that. Let's see if we can open it up again. All right. Well, I guess we could just add it into the Q&A box, or the chat box rather. Sorry, and just say
sure,
if you've heard of it.
Yeah, if you want to just type in the letter, that'll work. Okay, I see some people saying, I see a lot of answers. Okay, some people have heard of it, some haven't heard of it, some don't know much about it. I'm seeing most of the answers seem to be A, B, C, or D. Oh, some people do know it fairly well and are confident. So definitely share in the Q&A about how you use the ages. That would be great. Okay. So it seems like there's a big, you know, some people have heard of it and some haven't, and that's perfectly fine because I'm going to give you a primer on it right now, and then you can ask more complicated questions during the Q&A about it. So first of all, the A stands for attention. So this is really about the fact that your ability to attend to information is important for memory encoding, so getting that information in the first place. And we know that if you don't encode information effectively in the first place, knowledge has no chance to be stored, and so then it can't later be retrieved and used. So attention is really important, and it's affected by many things. So I already talked about the level of arousal of the prefrontal cortex and how it's best poised to learn when it's aroused at that optimal level, the sweet spot. And I gave you some examples of how we get people there. One example I can show you is this leaderboard example, where we have some sort of competition going on in the simulation. It's friendly competition to rev up the arousal. One thing to consider, though, is that there are no big consequences. It's a safe environment in the simulation, so it's not really that threatening because we also don't want to push people over, right? But it does increase arousal to help get them engaged. We also know that, and I'm sure you've heard of this, that multitasking isn't effective. There's a lot of research that shows that's not effective because we can't really do two conscious tasks at once because of how our prefrontal cortex works. What happens is we're really just switching between tasks really quickly. We think we're multitasking, but we're not. And multitasking has been shown to have a cost. So we're either less effective or less efficient or both at performing the tasks. And the amount of cost really depends on a few things, including how difficult the tasks are. Multitasking has been shown to reduce later memory performance, probably because people aren't properly encoding and consolidating memories in the first place. Now, the irony is that the research shows that people who tend to do it the most are also the least equipped to do so because they tend to have less cognitive control. And so you need cognitive control to be able to switch between tasks. So the main point is try to discourage this whenever possible during your learning programs if you want people to be concentrating on something. Now, how deeply you process something impacts learning and memory as well. So for example, if you ask someone something simple, like whether the third letter of a word is a vowel, that's structural processing, and that's pretty shallow. However, if you ask them about the meaning of the word, the semantics, you're processing the word more deeply and will be more likely to remember it. So what's interesting is that if you can relate the word to the learner and make it really personal, people will tend to have the best memory for that. So the reason why making it personal and also making people think about the meaning works so well is because when people are thinking about it in that way, they pull up their existing web of knowledge. So all the knowledge different pieces of knowledge they currently know. And so by doing that, they're doing a deeper level of processing and they're better embedding the new knowledge with the older knowledge they have. So deeper levels of processing during encoding leads to better later memory. So an example of how we do this is why we have learners go through simulations that are similar to what they might face on a daily basis. Because not only are they more likely to transfer learning to real life situations if they learned within a context similar to what they face in real life, doing this also makes the learning so much more personal and relevant to themselves. And we know that that leads to deeper levels of processing and better learning. So we naturally start to forget some of the material that's encoded after we encode it. So what you do with information after it's encoded and attended to has a very powerful impact on memory because we do start to forget. And oftentimes we will forget things before they're consolidated fully into long-term memory. So generation or testing can help prevent this forgetting. So it just refers to having learners come up with answers on their own rather than telling them, right? So I want to ask you guys a question. Are you currently using testing or generation to help learners acquire learning? And so by this, what I mean is, are you asking people, are you testing them along the way to acquire learning, or are you just using tests at the end after they've done a lot of study? And so the poll should be open. So
yes, the poll is open, and we have a few answers in. We'll give you a minute to complete the poll. We've got a lot of people finished. There's just a few last people that are finishing up their polls, so we'll give them a minute to do that. Okay, we'll close the poll. All right. So it looks like it's still calculating the responses for the last one, and we'll share the results with everyone.
okay, great.
It looks like we're kind of split.
Okay, so it looks like some people are using testing to acquire learning and some aren't. That's great to know. And if you aren't already using it, you might want to consider it, and I'll show you why. So a lot of the research supports this testing effect, that testing leads to better long-term memory. So after people are initially exposed to materials, learners are more likely to remember things long-term when they're tested regularly than if they study the material over and over. And you can see that on the right here. Right? So this is if you want things to be last longer than 5 minutes, then you're better off if you just do repeated testing rather than studying. And the reason why generation or testing is so effective is because it's more effortful than passive studying. Like I said, when you're generating, you're having to pull up current information, so that's making you embed the new learning better. And it's also helping in the consolidation process. So at Regis, we definitely use this principle, and we have some programs where people need to learn specific content knowledge, so we use testing to help people acquire learning or to reinforce learning. But you don't necessarily have to just use formal tests, though. I know a lot of people are hesitant to do a lot of testing. You can use less formal tests as well. So the more opportunities you can get people to generate information on their own, the better. So the debrief questions I showed you also make people generate information. So even just asking people questions, tough questions, will do that, okay? So not only do those questions activate the prefrontal cortex complex thinking, but the active generation itself makes it more likely that they will remember their insights once they reach them. Next is emotions. So emotion can be beneficial or detrimental to learning and memory. So I've already talked about how emotions, especially strong negative emotions, can be detrimental to developing insight. It can also be problematic for developing long-term memory of knowledge as well. So even though strong negative emotions can definitely lead to strong memories, because strong emotions, positive or negative, lead to better memories. And think about how PTSD and how those individuals who are traumatized by an event have very strong memories for things. Even so, you don't want to use strongly negative emotions in learning programs for a few reasons. First is the obvious. There's the ethical issue of inducing such strong negative emotions. But also, we know biologically it's not a good idea because chronic negative emotions affect the structure of our brain in a bad way. Do you remember I said that the hippocampus is really important for consolidating information and changing it from a short-term memory into a long-term memory? Well, when you're under a chronic stress or threats, there's some biological changes that happen to the hippocampus that make it less effective. So that means it's not going to be as good at changing something into a long-term memory, and so you don't want that. So that's something to consider. So if you're going to use emotions, you want to use positive emotions rather than negative emotions. Finally, there's spacing. So how you space out your study sessions impacts learning and memory. So after you've presented the information, most information will just naturally be forgotten over time before the final test unless it's reinforced in some way. This is the reason why we all study, right? And so you can see that in this typical forgetting curve. So if you just present the material once and then there's a delayed final test, depending on how long that interval is, you may have forgotten quite a bit. However, you can change this by having people study between presentation and the final test. But how you actually study during this interval here is actually very important. So after the initial presentation of the material, you can either mass or cram your study right before the test, or you can space out learning sessions across time. Okay, so that's what the blue here represents. And you notice that cumulatively it's the same amount of study time. The only difference is how that study time is distributed. So research across several decades shows that spacing learning sessions, so what you see on the bottom, across time leads to much better long-term retention. And this is something I wish I'd definitely known as a kid because I definitely did way too much cramming as a kid. So there's a couple things to think about, okay? So we know that spacing is more effective. Another thing to think about is how long you want people to retain the information. So if this final test is further out in time, and I'm assuming it is because I think most of us develop learning programs where we don't just want them to learn information for next week, but we want them to know it for a long period of time. If that's longer, then you need to space out these sessions more. Okay, that's just a general practice. But at the same time, you have to consider what is reasonable for the spacing here. Because if you space it out too far and they're too low on the forgetting curve, they may not be getting the impact of the spacing. The spacing may not be effective for them the way we want it to be. The whole idea with the spacing is we want to let them forget a little bit before we ask them again, so that we have that spacing effect. But if they've completely forgotten, that's also not great either. They will learn faster the next time, but ideally we get them before they have gotten that low on the curve. And the reason why this is effective is because having the spacing makes it effortful. You know, they've started to forget and they have to think about it. Before the next time they see it, they started to forget again, so they have to think about it. So it takes a lot of effort, and that effort and retrieval is what makes it so effective. So, and knowing what we know about the testing effect, this spacing is even more effective if it's spaced testing rather than spaced studying, right? So a lot of times you'll hear organizations say that they have a clear-cut formula for how to space things out. One question I always get asked when I talk about this is, well, how should I space this out? What exactly is your formula? Unfortunately, it's not that clear-cut. If you were to look at the research, it's not like there's one formula that fits all. It depends on so many different things. It depends on how far out is the final test. It depends on what do the learners know, who are the learners. It depends on the kind of material. It depends on how it's being presented. So there's so many different factors. But these are just some principles for you to think about as you're developing things. Ultimately, you do still need to use some judgment and then use some pilot testing to determine, are you doing the spacing at the right intervals? So here's a very simplified example of part of a program we're doing, so you can see how we're doing spacing with assessment. So we start with a routing assessment to determine which content people are weaker or stronger on, and that determines the recommendations of which content needs to be studied. So then the people get prioritized recommendations of what to study. So they might get content C as a high priority, and they get material to study, and after that, they're given a quiz on that material. Now, in our best practices, we tell them they should wait a while before they do this quiz, so they have a chance to do a little bit of forgetting. Now, based on this, their quiz performance, they get some feedback. And some of the feedback they get might be, oh, you need to revisit this material because you missed this question, right? And then they go on to other content, and they repeat that process with other content. So each time they get the content, quizzes, feedback, and they might have to review materials again. And then at a later point in time, we have a follow-up assessment where we then quiz them on the same kind of material they missed during the quizzes. And we know that this is especially effective. They especially need to be quizzed on material they missed. And so this also introduces that spacing element because there's been some time and some other things that have gone on before they get to this follow-up assessment. Now, there are other spacing opportunities that we have in this program as well, but this is one of the simpler examples. So just a couple tips about optimizing learning and making it stick, to summarize. You need to keep limitations of attention in mind. So think about the prefrontal cortex and how it's limited, how it works best, that kind of thing. You want to make learning personal as much as possible because it's better for processing, it's better for getting long-term learning and memory, it's better for so many things. It's better for learning transfer. You want to develop activities to include generation opportunities, so those testing opportunities I talked about, whether it's formal or informal. You want to use repeated testing rather than repeated study when possible. You want to use questions that encourage deeper processing. You want to be mindful of the emotional impact of your program. So rather than using strong, chronic, negative emotions, you want to induce positive emotions, and you can do that through entertainment or other means. You want to incorporate spacing into your program. And I see that someone has said that game and simulation is one great way to incorporate some emotions as well, make it entertaining. In terms of spacing, you want to incorporate spacing opportunities into your program, and ideally, if it's possible, spaced testing, not just spaced studying. And you want to consider the retention period and other factors that I mentioned to determine the spacing. Like I said, there's no one-fits-all formula, but there are some principles that can be helpful. So I want to ask you, I've talked quite a bit today. I want to take the next minute or two for you to consider how can you apply some of this information to your work. So I want you to think about examples of how either the AGES model might be helpful or how what I talked about insights. And anything you would love to share, we'd love to hear from you in the chat box. Yeah, so I think Autumn has that question. So when you talked about the flipped classroom, yeah, I think if I'm understanding what you're saying from what I've heard about the flipped classroom, that term, it does seem that's when you use a lot of questioning, right? And it's more it's rather than you have people teach back things. Is that correct? So you have the students teaching things or doing more of the leading rather than having someone teaching and. So it's when you give. So you're saying it's when you give information first. Okay. So I'm seeing a lot of comments here. Let's see. Someone is asking me to go back on the slide. So let me go back a slide. Is this the slide that you wanted? Balman Kell is saying, as an extrovert presenter, I've started including pauses when changing to different topics so that people can have a moment to reflect and capture a key takeaway. Yeah, definitely. I need to get better at that. I've been told I talk way too quickly and don't have enough pauses. So, but yeah, that is a great way of application. Any other thoughts about how to apply some of these things?
Vicki had a great comment. Vicki had a great comment about this is a good reminder of the importance of the type of questions that go into the debrief because they have specific purposes.
Yeah, definitely, definitely. I think sometimes we want to ask questions, but we don't think enough ahead of time of what we're hoping to get from that, what kind of thinking we're trying to encourage with that. So that should definitely be the guider of asking questions. You don't want to ask questions for the sake of it, but because you really want to do something with it. Yeah, so.
Oh, I like that idea that somebody said about the idea of making learning personal and the importance of getting to know the audience. That's very important.
Yeah.
So you can ask those questions.
Definitely. Thanks, Patrick. Yeah, I think that knowing the reasoning behind why you do, because I know some of you already are probably using some of these things, but I also know that when you develop a learning program, you have to defend it. We have to do it all the time. So it's helpful to know the science behind it. And there's definitely so much more I could share. I wish I had 3 hours to talk to you guys. So. Marshall saying, I include opportunities for participants to discuss their insights with others at the table. Yeah, that's a great thing to do. I think that's when, because people can act as the ACC for other people as well, because they will, they will question other people. So when they start talking about something, you'll have someone who questions something, and that gets them to think differently. Let's see. Queen Mavor is saying this is helping to make explicit something that I think I rely on intuition to do. Yeah, I'm sure a lot of you have some great processes that you're already doing, and I think by making it explicit, you can be more deliberate. I think it's great to have that intuition, but I think if you know the principles and you know the research behind it, then you can be more deliberate in thinking about, well, how can I make sure I'm baking this into my learning programs? Thanks, Penny. Yeah, no, definitely. I think the recording will be shared afterwards. I think tomorrow by Julie. Yeah. So in the flipped, okay. So Maria's saying in the flipped classroom, video lectures are viewed first, and then during the class. Yeah. So that does use some of these principles. So essentially, you are seeing the material ahead of time, but then you're doing something more active or experiential in the actual classroom to apply and use the information in different ways. So it's a less passive way of getting the material, which is great, because when you're active and you're experiential, you engage with it so much more, and you're more likely to remember it and learn it well. Okay, so Autumn is saying, I have a question. How can I monitor the biological arousal if I'm training via webinar, meaning I don't have a personal interaction with the user? That's a really good question. It's really difficult. It also depends on what kind of webinar you're doing. Obviously, with a webinar like this, where there are a lot of people, it's a little bit harder than when you have more regular webinars. So when I taught a lot, I was teaching smaller webinars with the same people. And so there's a lot of input from the students, a lot more chatting, a lot more breaks. I think a lot of it is probably checking in more with people during those webinars. If you have video, you can also see it on their faces, quite honestly, because you can tell when someone's not very engaged or someone is starting to drift off a little bit. But if you don't have video, definitely making sure that you're engaging them with questions in between, asking them to participate, asking them how would they use the information. So you can at least try to prevent them from being disengaged and making sure that they have the right arousal. But actually checking that is really just about checking in more with people, so more regularly. Any other thoughts or questions? So you can keep typing them in. I am going to also just pull up my information in case you, after this, come up with something and you want to reach out. I have my email, the website, and my LinkedIn contact if you want to connect with me as well. So, but I have a few minutes, so if anyone has any other questions, feel free to, or thoughts, feel free to share. Oh, so Marshall is giving a tip. I think that telling them you may call on them randomly keeps their biological arousal up. Yeah, it's a bit of a fear, but it works. And yeah, and actually I used to do that with my students. So I taught a master's in neuroleadership class for NLI, and I think that definitely keeps them on their toes, you know, knowing that you may be asking them something at some point. So yeah, good tip. Any other thoughts? Well, thank you all so much for joining. I really enjoyed hearing from you guys, and I look forward to connecting. So,
well, thank you so much for sharing all this great information today. And I'm sure that all of us can find ways to apply it into our training. That last slide, slide 38, with the AGES model, we will share that along with the materials tomorrow. The other handout that we have for you is that System 2 Thinking white paper from the Regis group, or the Regis Company, sorry, that Grace has so kindly shared with us. So yes, the answer to whether or not the recording will be shared, the answer is definitely yes. That information will be probably posted through the actual ATD site. I believe we have a YouTube channel where that kind of stuff is posted. So more on that later, but we'll be sure that you have that information if you want it. Grace, we just want to thank you so much for being here with us today, and thank all of our participants today. This was a great 60 minutes of a lot of really engaging and informative material, and we really thank you for being here.
Thank you all so much. Thank you.
So we invite you to complete the survey that will pop up when you shut down out of this webinar, and please feel free to check the ATD NYC website for future events of this nature and future webinars, and also encourage you to become a member of the New York City chapter. There's a lot of great events that go on regularly and a lot of great networking and great conversations like we experienced here in the chat box. So, but you can also take it face-to-face if you come to the in-person events. So thank you once again, everyone. We promise to end on time, and we will. Thanks so much.